So we have considered a body which is encountering the free stream velocity u infinity, and the boundary layer is growing in this manner. So this is the boundary layer. So we have taken this point, and with respect to this point we are taking the growth of the boundary layer. So the growth in the boundary layer is represented by the function delta. So we will start by writing the 2D Navier-Stokes equation. So when we will write the 2D Navier-Stokes equation for the mass conservation, we will have this as first equation, and for the x momentum and y momentum we will have the equations as u del u by del x plus v del u by del y is minus 1 upon rho del p by del y plus nu times So similarly for the y momentum, u del v by del x plus v del v by del y is minus 1 upon rho. Okay, what I did here, this would be x, this would be x. This would be y, sorry, and this new del 2 v by del x square plus del 2 v by del y square. So as we see that there is no v in the free stream velocity, but there is v in the but in the boundary layer regime, to capture the growth of v also, we would try to non-dimensionalize the variables. So after non-dimensionalizing, then we will try to capture the nature. So if we non-dimensionalize each of the variable, we can represent the non-dimensionalized variable by by putting prime against them. So if we non-dimensionalize each of the variable, we get the following. For dimensionalizing the length, we can use the length of this plate as L, and for non-dimensionalizing y, we can get by the delta, the growth, and for the for the pressure, we will non-dimensionalize it by the free stream pressure, and the time variable we will non-dimensionalize by simply x by how we will non-dimensionalize it, L by u infinity, because it gives the time dimension. So now if we replace this in the continuity equations, in the Navier-Stokes equation, what we will get is, if I replace u dash by this, v dash by this, we will get u infinity by L del u dash by del x dash plus v infinity by delta del v dash by del y dash is equal to 0. So from here we find that the order of u infinity by L should be the order of v infinity by delta. This would be very important in analyzing the further equations. And so from here we arrive the first Navier-Stokes equation for the boundary layer, that is del u dash by del x dash plus del v dash by del y dash is 0. This is our first equation. So now moving on to the momentum equation, by non-dimensionalizing it, we will have u infinity square by L del u dash by del t dash, here it is right, plus u infinity square by L del u dash by del x dash plus u infinity v infinity by L square del v dash by del u dash by del y dash is equal to minus 1 upon rho u infinity square by L del p dash by del x dash plus nu times u infinity square by L del 2 u dash by del x dash whole square plus v infinity square by delta del v dash by del y dash whole square del 2 v dash by. So here we see that okay, something seems wrong. U infinity square by L and yes, so I have made a mistake here. It would be u infinity by L square and v infinity by delta square, because x is whole square, so the non-dimensionalizing parameter would be square. So if we analyze both these terms, we find that we have in boundary layer that delta is very less than L. The growth of the boundary layer is very small with respect to the body length. So here we can very easily say that that this term would be much smaller with respect to this term. So in comparison of this term, we can neglect this term. So if we now write the equation, we can take u infinity whole square by L common, because here also I made a mistake. It would be delta. So u infinity by L is same as v infinity by delta. So if I take this common, it would be plus del y dash as u infinity square by L del p dash by del x dash plus nu times v infinity by delta square del 2 v dash by del y dash square. So in the boundary layer regime, the viscous flow term would be the order of magnitude of the pressure gradient term. Otherwise like we would not capture the growth of the boundary layer. So from here we will have again an important comparison that u infinity square by L should be the order of nu times u infinity by delta square. This order should be same, and then we will have the equation that del u dash by del t dash plus del u dash by del x dash plus del u dash by del y dash is del minus del p dash by del x dash plus del 2 u dash by del y dash whole square. So this is our second Navier-Stokes equation for the boundary layer. Similarly, for the y momentum equation, we will have from del v dash by del t dash, we will have for v we will have v infinity, and t we will have L by u infinity. So u infinity v infinity by L del v dash by del t dash. For this we will have again u infinity v infinity by L del v dash by del x dash. For this we will have simply v infinity square by delta del v dash by del y dash plus is equal to minus 1 upon rho u infinity whole square delta del p dash by del y dash plus nu times we will have v infinity square by L del 2 v dash by del x dash whole square plus For this we will have again v infinity square by delta and del v dash whole square by del 2 y dash. So again I made this mistake here, that this would be square, not this, again because this is whole square. Okay, so now here if we collect the terms on LHS and RHS, we will have u infinity v infinity by L del v dash by del t dash plus del v dash by del x dash, again u infinity by delta. I missed this equation. Again if we analyze it, what was I saying? Yes, so the v infinity by delta we can write as u infinity by L, so it would also be commoned out. This is, and this would be my u infinity square by delta del p dash by del y dash minus, and in this here we see that this term would be much smaller compared to this term because delta is very very less than L, so we can neglect this with respect to this. So it would be simply nu times v infinity by delta square del 2 v dash by del y dash whole square. So if we analyze the order of terms of this and this and this, we see that first we have analyzed that this is of order of this, so we can have both of the order of these two would be approximately same, and it would be much less compared to the order of this. So we would have u infinity square by delta order would be much greater than the order of this. So simply from here we can say that we can neglect these two terms compared to this term, and it would give us the third equation as del p dash by del y dash equal to 0, which is our third equation for the boundary layer Navier-Stokes.